Hello, Open XML developers. This is Eric White. In a previous screencast, I demonstrated some code to do high-performance Open XML document processing. This code has a few unique features. It uses MSMQ to talk back and forth between a controller program and a daemon. It also has the ability to stop processing on code if the code takes too long. It also looks for any exceptions that are thrown in the code, and each daemon reports such exceptions back to the controller program. I think it's worthwhile to walk through this code so that if you need to implement this exact scenario, you can do so in as easy a fashion as possible. So let's go look at some code. Let's first take a look at the code for each of those daemons that I demonstrated in the previous screencast. I discussed in that screencast there are a few variables up at the top of this class in the daemon code that initialize such things such as the daemon number, the controller machine name. That's the machine that is running the controller process that controls all of the daemons. We have the controller queue remote name, and then we also have the process documents queue local name and the process documents queue remote name. The process documents queue local name, this is the name by which we have to refer to this queue on the machine that is running the daemon. The process documents queue remote name, that's the name of the queue that the controller needs to use to refer to that particular queue. As you could infer from this code, the names of the queues for the process documents queues are process documents 1, process documents 2, etc. through process documents 4. The first thing that this code does is it calls this initialize method. And in this initialize method, it looks first for the process documents queue that is on this machine and the one that is for this daemon. And if that queue exists, it deletes it. And then it creates a new one. We don't want to use any old queues that happen to be laying around. After the daemon calls the initialize method, it calls this message loop method. And if we go to this method, first thing it does is waits for a message to come in on its queue. It blocks at this process documents queue.receive method. You can write code with MSMQ to not block, and it will then throw an exception after a certain amount of time, and sometimes that's appropriate. You maybe need to take some other actions in the meantime and not block solely on that queue. In this particular case, it's quite okay to block on that queue. After this daemon gets a message on that queue, it gets out the process documents message text from that message. This is, as it were, the payload of that queue. This is going to contain some XML that we design so that we can pass the information back and forth as we need to. When you're building some customized version of this example program, you'll most likely want to change the information that is in these payloads that go back and forth. We can see what the various payloads look like up here in this comment. The payload that comes in with this process documents message has this XML right here. We can see that the controller queue name is right here. This is the remote queue name. So here in this daemon, if we send a message to this queue here, we'll be sending a message back to that controller. The controller also informs the daemon where the various directories are to operate. So it tells where the source documents are and where the processed documents are. Also, that controller tells what is the timeout value that we want to use for this particular process. It then has document process info with a list of documents. These are the documents that the daemon should operate on and then send a message back indicating that it has done so. Here is the message that the daemon is going to send back to the controller. The message label is process documents complete. The daemon sends back the name of its own queue, the process documents queue that is local on the machine that's running that daemon. And this is the name of the queue such that the controller can send a message to this queue name, and this message will be received by this particular daemon. So the daemon is telling the controller that I am the person who just got done processing these documents. It then sends back a list of the documents that were processed, and if there were no errors, it just sends back the name of the document with no other content in this document element in the XML. However, if there was an error, then it embeds a child element to that document element, and that child element has a tag name of error. It has an attribute of exception in this case. The other case we can see is we'll have a type equals timeout if the process just took too much time, and then we send the actual text of the exception back to the controller. And that way the controller can take all of these reports and aggregate them together into one big report that you can then look at or process as appropriate on that controller machine. Okay, now we're back down here looking at the code further. We're going to get the various pieces of information out of that XML that was passed as the payload of the message to that daemon. The daemon then calls this document processor.process documents. That's going to return some XML that is going to be the report that we want to send back to the controller. We then see that the daemon fabricates the message to send back to the controller with the report in that message. It sets the label to process documents complete and sends the message, and then it continues on with the loop waiting for the next message. Now let's look at this process documents method. This has some interesting stuff in it. As I told you, we want to be able to abort processing if we take too much time. So the only way to do that is we actually put the processing of the document in its own thread. Now, this isn't really creating a multi-threaded application of the kind that we need to watch out for, because only this one thread will be accessing the Open XML SDK, and therefore only one process will be accessing that secret directory in isolated storage. So the way this code works is we create a new thread, we do the processing. If we get down to below this save as call, it means that everything worked just fine, and we can put together the doc report and append it to the report and continue on. If we get the thread abort exception, that meant that we timed out, and we need to put together that XML that indicates that the processing timed out for this particular document. And if we get any other exception, then we put together a doc report that contains the error element with the attribute of type is equal to exception, and then we call toString on that exception and put that into the doc report. Now you'll notice this one little thing we call this method make valid XML, and that's because when you call toString on an exception, there are certainly cases where there are characters in that string that are invalid in the XML. So if we look at this method make valid XML, it's just a simple little method that iterates through all of the characters in that string, and if any of those characters are less than 0x20, in other words less than a space, it replaces that with a underbar and the hexadecimal number for that character, and it returns the string with those control characters replaced with another format for those control characters. And this enables us to put the exception string itself right in the XML. If we didn't do this, we would end up with invalid XML. It wouldn't serialize. We'd get an error when we tried to serialize it. Dropping down here, we look to see if timeout in seconds is not equal to null. One key point here is that in this message up here going to the daemon, you can simply eliminate this element timeout in seconds, and then it won't ever time out. You hopefully then have code that you're very confident will never hang or never take too long to execute. So if timeout in seconds is not equal to null, we create a new timer. We set it to the appropriate number of milliseconds, and we set an event handler such that if this event handler fires, then we abort the thread. Following that, we start the thread and join the thread. This is standard .NET multi-threaded programming. This join method is going to block until that thread terminates, and it might terminate because the thread simply finishes, and it might terminate because thread.abort got called by that event handler for the timer. Immediately after returning from joining that thread, it disables the timer if the timer happens to still be enabled. It then writes a couple of things to console and so on and so forth. All of that's not very important. That's all that this particular daemon does. The specialness in this particular daemon code is that we put the processing in its own thread, and then we set a timer so that when the timer goes off, we can kill the thread if the thread hasn't finished already. And then we can have the daemon let the controller know what happened. Now let's go back and look a little bit through this controller code. The first thing that the controller code does is it calls the initialize method, and this initialize method, first of all, sets up the correct name for all of the remote queues that it's going to be talking to. It also looks for if the processed documents directory exists, and if it doesn't exist, it creates it. It looks to see if its own controller queue exists, and if it does, it deletes it, and then it creates its own controller queue. So this is the one queue that lives on the controller that all of the daemons send messages back to. It then iterates through each one of the remote queues, sending a ping message to those remote queues. Now if we come back over here real quickly to the daemon, when we see this ping message, it calls this send ready message method, and the send ready message now sends a ready message back to the controller. Let's go back to the controller now. When the controller receives this ready message, then it goes through the process of determining the number of documents to process and putting together the payload for the message that's going to go to the daemon, asking for the daemon to do the appropriate processing on those documents. One thing that I have found out is that it's inconvenient if you simply have every daemon always operate on, say, 100 documents, because then what you'll find out is all 3 of the daemons are finished right at the time that the 4th daemon starts processing on 100 documents, and then you have to sit there and watch that last daemon finish before you can get your report. I take this little approach here where I calculate the number of documents to process based on the number of daemons and based on the remaining documents to process. And we get that by the total documents to process minus the documents requested. By documents requested, that means the controller has requested that the daemon process that document. We set this documents for this job to either the minimum of the maximum documents per request, or this value that I calculate based on the number of documents that are left and based on the number of daemons. It also sets the value so that we never ask the daemon to process 0 documents. That wouldn't make sense. We put together the XML that's going to go in that message to the daemon and send the message. It then keeps track of the number of documents that have been requested of that daemon to be processed. And we can see up here when we're putting together the list of documents, we take the document list, we skip the total number of documents that have been requested, and then we take the number of documents that we've decided that we want to take for this particular job. When that daemon gets done, it sends the process documents complete message that we saw. And here we parse the XML that is in that message. We get the report for that particular job and add it to the overall report, this run report. We keep track of the total number of documents that have been processed now. We calculate the speed that things are operating. In other words, we calculate the documents per minute and display it. And then last, we look to see if we're actually done. And if we are done, it does something here where it actually sorts all of the documents in the final report by their document name. We want to do this because this cleans up that report so that when we look at it in an editor, all of the documents are in order. We don't necessarily know when we request a certain set of documents to be processed by a daemon, whether a daemon that is further down the line is going to finish sooner because all of its documents were easier to process. So by sorting all of those documents at this point in time, it makes our report neater. Another thing that it makes it possible to do is to use something like WinDiff and compare 2 reports and see if we're getting the exact same results with both runs. That's sometimes important. I, for instance, used this particular approach to validate that the validation functionality in the open source version of the Open XML SDK performs exactly the same as the validation functionality in the official binary release of the Open XML SDK. In other words, I ran a process to validate every document in a large directory. I got all of the errors as reported by the official binary release of the Open XML SDK, and I made a report of that. And certainly many of those documents in that particular directory failed, some of which I had made fail intentionally. I had gone into those documents and made the documents be invalid in a certain way that I wanted to make them be invalid. I then built the exact same program using the open source version of the Open XML SDK. I ran both processes and then I compared the resulting report, and then I felt confident that the document validation functionality in the open source version of the Open XML SDK matches up exactly to the document validation functionality in the official binary release of the Open XML SDK. Well, there you have it. I've walked through the code in quite a bit of detail. I think that should be enough information to get you going if you need to take this code and modify it for your particular scenario. Thanks for watching this video. Thanks for using Open XML. Talk to you later.